Hello and welcome all to the channel Journey of Solar Energy with Sunny. So today we are going to start with PVsyst software and it's learning from the basic or starts how you can install it, what is PVsyst software, what are the details, what are the necessities, how it is working, and all this today we are going to discuss in this video. So I am your friend Snehal Vijay Kumar Purani, lecturer in Electrical Engineering Department, Sri KJ Polytechnic, Bharuch. So now, what is about this PVsyst software? So it is one of the oldest photovoltaic software developed by the University of Geneva. This is a powerful software tool for the photovoltaic systems. It designed to be used by architects, engineers and researchers for their purposes or for the researches. It is also a very useful educative tool. It includes a detailed contextual help menu that explains the procedures and models that are used and offers a user-friendly approach with a guide to develop a project. PVsyst is able to import metadata as well as personal data from many different users. It is most widely used for solar simulation software for the energy yield estimation and for optimal design of solar power plants. PVsyst makes use of the extended knowledge of photovoltaic technology, meteorological irradiation resources data from NASA and Meteorome and PV system components. Thus, PVsyst will help in understanding the PV system components and thus help in optimizing the engineering or system design. Given future scenarios, renewable energy sources, in particular photovoltaic technology, will develop quickly with the development in the semiconductor technology and the art to convert the energy from the sun to electricity. This has to be done in a sustainable way using the best technical or economical solutions. So we can design best techno-economical solution using this software tool. So what is PVsyst all about? Why it is introduced? What are the objectives of this software? So it is an essential tool to develop PV technology in optimal and reliable way. Pursuing this objective, the PVsyst software is a tool that allows its user to accurately analyze different configurations like grid connected mode, islanded mode, and to evaluate the results and identify the best possible solution. The PVsyst team is committed to developing the software in a way that ensures its sustainability. The development of PV technology depends on the existence of a large group of highly qualified professionals. To meet the needs of the professional qualified engineers, PVsyst provides specific training on PV technologies and the PVsyst software. Renewable energies are of major importance nowadays for the saving of this Mother Earth planet and developing the countries. We will support energy projects that are focused on the acquisition of autonomy. So PVsyst features are, some of the features on the design board is, the design is based on a quick and simple procedure. Specify the desired power or available area. Choose the PV module from internal database available. Choose the inverter from the internal database available. PVsyst will propose an array or system configuration that allows you to conduct a preliminary simulation or basic simulation. The software embeds a color-coded warning error messages system. If there's a mismatch issue warning with your design, you will be warned with the proper frame and proper comments, so you can implement those suggestions in your design for the proper design. So this is the front dashboard or front look of the system design. So you can use this PV array and orientation for your design. You can either enter the planned power you design or the area available with you. You can select the PV modules available in this. You can use the inverter available directly in this. It will suggest you the number of strings and number of series for the PV module array configuration. It can give you the effect of P norm, number of modules, area required, its sizing, etc. is here. and if any warning is available or your design is not proper, it will give you error message in this rectangular box. So this is how you can use this interface and you can input your required data. Now, PVsyst another features are system sizing. It is giving us a liberty to use this tool for available of size. So a specific tool gathers all constraints for the sizing of the systems, like for the number of modules in series. The upper diagram shows the IV curve of the PV array together with maximum power point tracking range, voltage, power and current limits of the inverter you have chosen. For the inverter sizing, the second graph displays the annual distribution. This annual distribution of power or array power with the array and inverter nominal power. The optimal sizing of the inverter is based on the acceptable overload throughout the year. It usually leads to oversize the power ratio, that is array nominal power by respect to the inverter nominal AC power by a factor of 1.25, that is the safety margin. This is available in this. So you can use or design your power as per the sizing. So array sizing, array voltage sizing and inverter output sizing or distribution can be adjusted using this. These graphs are based on the temperature you have given as an input in the network. After good system sizing, you can define different losses like far and near shading using a full 3D editor for the definition of the environmental and near shading conditions. Specialized tools are also provided for the evaluation of the wiring losses like ohmic losses, module quality losses, module mismatch losses, soiling losses, thermal behavior according to the mechanical mounting, system unavailability, etc. You can define in your system design using this software tool. Now, what is the 3D shading scene? So this tool or this software is readily give you the facility of creation of 3D shading tools, user-friendly object manipulation and creation in this tool. You can easily import an external design using computer-aided design or AutoCAD or SketchUp or Helios. You can directly use those developed available shading scenes directly in this software for the analysis purpose. Quick design will help you to design your shading layouts and zones of tables, etc. Orientation identification and scene validation tools are also available. Sun point of view simulation is also available. Multi-threaded shading conditions or calculations you can easily calculate or perform using this PVsyst tool. The reports and simulation is very important of this tool. This simulation calculates the distribution of energies throughout the year, that is for 365 days 24/7 availability of the solar energy. Mind well, this solar energy calculation is based on the sunrise time to sun set time. So main results are based on the total energy production. It is essential for the evaluation of the PV system's profitability. The performance ratio describes the quality of the system itself. The specific energy is an indicator of the production based on the available irradiation that is at on this location and the orientation of the panels you have decided. It shows the main energies and gains or losses involved in the simulation practices. Powerful tool for a quick analysis of the system's behavior and potential improvements in the design. So this is the loss diagram available. It shows the amount of global irradiation available on the solar incidence or the solar module. This is effective irradiation on collector. This is the available insolation at the solar plate. This is after the conversion. This is the module efficiency, that is array efficiency 12.92%, which converts this amount of energy into this. So this is the array nominal energy. Using this at different stages, different types of losses, the amount of energy available at the inverter output, the same amount of energy is being injected into grid, as we have selected only grid connected mode for this simulation. So now again, what are the features available as compared to the design? So one of the feature is grid storage. So storage in a grid system is a complex feature, as it may have different objectives which lead to different strategies and different PV system configurations. Up to now, we have developed 3 strategies in PVsyst. One is for the storage for enhancing the self-consumption of the PV system owner. A storage for ensuring peak saving when the possible power injected into the grid is limited. A storage for the continuity of the user's electricity feeding when the grid is weak or not available or it is offline. In each case, the energy fluxes are different and lead to different simulation results. As an example, we show the energies involved in a self-consumption of PV system like this. So, this amount of energy is available by inverter at the output terminals. This is the amount of usage by battery storage, battery global losses, battery output inverter losses, and this amount of energy is dispatched to user and grid re-injection. So these are the amount of energy available at the terminal. So this is the graph. This is the PV system, EPV available. This is the battery storage. This is user. If grid is weak, you can directly use this solar, and if not, we can charge the battery and battery will dispatch the available amount of energy when needed. You can take this energy from the grid itself. So there is a requirement of a bidirectional energy system conversion from a normal energy meter to a bidirectional meter at your terminals. We can install the available metronome data once while you are opening this. You can also use metronome data of NASA as well for the simulation purpose for any location available on the earth. So this is how you can use your geographical coordinates. This is the basic available geographical network, and for this, for your location, you can insert the latitude, longitude, altitude and time zone details here and get from the name or sun pass. You can directly choose from this tab, and metronome data for this you can use metronome itself, NASA or PVGIS agencies. You can import this data and add to this site. Now PVsyst modules and model management. So in this, Sendia model implementation and comparison with PVsyst model is done. Tools for optimization parameters like low lights, IV curves, etc. New parameters like amount of tolerances, incident angle modifier profile, V maximum of ultraviolet and user defined voltage levels, optimizers, solar age and maxim. Inverter configurations, so new parameters like transfer CEC efficiency can be calculated, multi-MPPT with asymmetrical input or unbalanced input, and advanced power sharing possibility or opportunities is there. So improvement of the choice by the manufacturer. Besides this, you can use your user defined PV modules and inverters and feed your data in .ond file and .ond files. You can use your data. So using this optimizer, you can use this optimizer for the easy calculation if you are unaware of anything or you just design a basic design of this tool. Also, the aging and multi-year batch simulation is performed using this tool. For different operating years, same meteor data is available. For a set of yearly meteor data files is easily available. Results and graphicals approaches or representations are available on the report. You can add or insert the same graph in the report as well for the documentation purpose. So this is how you can use this aging effect and aging tool for simulation purpose and generate the report for the same. Also, bifacial calculations are easily available with this, as we are nowadays using bifacial modules. In this, you can using the reflection of the sun rays from the terrace roof itself. So bifacial models have the better efficiency as compared to this monofacial efficiency. In this bifacial model for tracking one axis system or unlimited trackers is available. This will improve the import parameters from the real system defined in the 3D design. Conceptual error in the model which lead to an underestimated or underestimation of the rear side irradiation by the factor of 1 divided by GCR, that is a factor of 2 or more. Add the contribution of the diffuse seen by the rear side, albedo in monthly values, seasonal orientation, that is possibility of negative summer tilt for low latitudes. So this is how you can design these unlimited shades for 2D models using bifacial design. This is available for you. You can use your tilt, azimuth angle, the pitch for which, and the amount of total shades available, profit angle, profile angle limit. Everything can be adjusted by you for the betterment, and you can select the month, daily radiation for the clear sky. You can select your month, and the available metronome data is here. So this is how you can use for the bifacial design. Batch calculation can be done using this tool. So batch mode and shade optimization tool is available. Modification of the pitch as the parameter, bifacial height above the ground as the parameter, you can implement in it for the better generation. So these are some parameters you can use for the simulation of bifacial network as well. One of the most feature that you like is available in this tool is the economical evaluation, as this attracts the amount, the cost or the system pricing based on which you can use your design is this function of the PVsyst feature. So this PVsyst is featuring the economical evaluation for the better judgment by the end users or the consumers whether they are going to install this or not, whether it is beneficial or not, whether the capital investment is recovered or not. These all are available in this tool itself. So economical evaluation tab, you can directly input system cost evaluation, that is capital investment, that is capital expenditure, installation cost, OPEX, that is operational expenditures, that is operating costs, ability to define customized cost according to the system. The pricing strategy, that is detailed feed-in tariffs definitions, that is the amount you are feeding or giving back to the grid. You have the rate available for this, in which the grid or distribution company is buying energy from you. So this is available in the contract between you and distribution company, whether it is fixed or variable or customized, hourly or seasonal variation. In India, in Gujarat particularly, if we are considering this, the feed-in tariff, in this the policy defined by the distribution company is that the number of units generated by the customer is directly deducted from the number of units consumed, and if any surplus amount of units are still generated by the users or the customer or consumer, this will be given as a benefit of 2.15 paise or 2.25 paise or 2.5 paise as per the contract between the distribution company and this consumer. The selling policy, that is connection tax, yearly tariff variation, duration of tariff warranty, etc. is directly can be given as an input. You can give the parameters for the self-consumption economy, advanced financial analysis, that is funds distribution, that is your own funds, or you have taken any loan or subsidies from the government or any banks, etc., or any other organizations. The net present value NPV and levelized cost of energy calculation can be done using this tool. Inflation, discount rate and detailed depreciation management is also incorporated in this tool for the exact scenario simulation. The profitability analysis, that is yearly balance, payback period and return on investment, can be done using this tool. Graphical results and tables and plots are easily available for the better understanding of this. So this is how you can use, or this graphical representation can be seen using these plots. This is the tabular available facilities that shows the whether the generation or whether this investment is profitable or not. All this kind of generation or simulation results are available on this screen. So this shows the payback period is 6.1 years, which shows that operational life is 25 years, and the investment that we have done for this installation is recovered in 6.1 years, means this payback period is smaller than the amount of the operational life. So this generation or this installation is a profitable one, so you can install or this. The return on investment is like this, that is 448.6%. You can choose the currency. Here it is available in euros. You can convert either in dollars or in Indian National Rupees INR as per the requirement for the simulation. Now, for the installation requirements, PVsyst is not meant to run on a server or on a remote desktop client. It has to be installed on the workstation where it will be used. PVsyst runs only under Windows with a virtual machine for others OS like VirtualBox, Parallels, etc. The program works properly in full license mode only if the computer's date and time are correct and have never been modified. PVsyst is not liable if the program does not work because the computer's clock has been changed. So these are some requirements of the operating system. System not supported by it. Other requirements like at least 1 GB of RAM, 1 GB of free hard drive space, minimal screen resolution is 1280 and 720 pixels. .NET Framework 4.8 is available for the Metronome support. Graphical support OpenGL 2.0 or higher. PVsyst Workspace does not support shared or remotely synchronized drives, folders or files, and Workspace can be synchronized as a separate task once PVsyst has been closed. So this is how you can start with the PVsyst. Go to Google, type PVsyst software download. This link is provided, and from this link you can download the software. The above link will inform you about the new version, 1 month free trial with required system configuration details. So here I am showing you that we have downloaded 6.7 setup, 6.7 license agreement. Next, ready to install PVsyst. After the installation, it will show you this: completed the PVsyst setup wizard. Click finish button to exit the setup wizard. And after the installation completion, you can see this kind of PVsyst 6.7 logo and shortcut. Using this, you can directly use this software tool for your purpose. Thank you for the patience hearing. Thank you so much.